Hey everybody, it's Miss Kathy from the Merrimack Public Library, and thank you for joining me for another Elementary Explorers. So, today we are going to talk about how we can use bubble solution in winter to explore the scientific method. And states of matter. So, there are a couple different things that you can experiment with. At the heart of this challenge, at the heart of this exploration, is just the fact that bubble solution is mostly water. So if you blow bubbles when it's cold outside, below 32 degrees, water freezes. So that's the heart of the experiment, but there are a number of ways we can sort of change the variables and see how that changes our results. So the first thing we can play with is our bubble solution. We can use like a standard bubble solution like we would grab in the summer, but we also could make our own. I saw one person who did this experiment by making bubble solution out of warm water and dish soap. And I saw another person who suggested adding corn syrup to the dish soap and the water to make it even thicker. The thicker your bubble solution is, the more the bubble is going to hold together. And that's important when you're blowing bubbles in really cold temperatures, because a thinner bubble solution, like what I've just been blowing, is going to pop much more easily than a thicker bubble solution. The second thing you can experiment with is the temperature. So in this case, we want the bubbles to freeze as whole as possible. That way we can watch the ice crystals form on the outside of the bubble. And there are 3 layers in the surface of a bubble. There's the inside, the outside, and the water in the middle. And the water in the middle is what actually freezes. So you need the bubble solution to hold the water in place long enough for the water to freeze. So it's going to freeze faster at colder temperatures. So generally, colder is better. You can do this by blowing bubbles onto a plate and sticking them in your freezer. But since we have these cold temperatures in January anyways normally, and right now we're like in the teens, it works to take it outside. So in theory, anywhere underneath 32 degrees, the water will freeze. But the colder it is, the faster it freezes, the less chance there is that the bubble's going to pop. So you could try it on a day that's 28 degrees and 15 degrees and 6 degrees, and you're going to get different results because the temperatures are different. So you can experiment with the bubble solution, you can experiment with the outside temperature, you can also experiment with the temperature of the air blowing the bubble. If I'm blowing the bubble with my breath, that's quite warm air. If I put bubble solution on the tip of a squeeze bottle and then squeezed the air out of the bottle to blow the bubble, that air is going to be much colder than the air that's coming out of my lungs. So you can experiment with the outside temperature, you could experiment with the temperature of the air, you also could try to experiment with the temperature of your bubble solution and see if you have better luck if it starts colder or warmer. So you can experiment with the things that make up your bubble solution. You can experiment with the temperature of your bubble solution and the air outside of the bubble and inside of the bubble. There are a couple hints, a couple tricks I found that make this more successful that you can try and see how it works for you. So one source said that you should start by blowing the bubbles onto a flat surface. So they recommended blowing your bubbles right onto the snow or onto like a cold bench or table, because the bubble will land on the surface and it's less likely to pop if it's freezing to a surface than if you're trying to get it freeze while it's floating in the air. And that way, the wind is less likely to blow it away before you can see the reaction happen. So you could try blowing your bubbles onto different types of surfaces, different temperatures of surfaces. There are a lot of different variables that you can experiment with, and you can make your hypothesis, what you think is going to happen if you change the temperature or change the bubble solution. I've given you some of my hypotheses as I explained the differences. So you have what you think is going to happen. You do the experiment and see what happens, and then you can figure out why. So there are a lot of different things to play with while you're playing with bubbles. And it's pretty scalable because you can really break this down like a science experiment, or you can just have fun with it. But be patient. Just like it takes time to learn to blow bubbles in the summer, it's going to take time to dial in exactly how to blow bubbles in the winter. It does seem like it's a little bit different and the bubbles pop really easily because the air is really dry. So don't get discouraged if your bubbles pop and it takes you a while to get this to work. But when you do figure out what makes it work, you have a wonderful, successful science experiment. So I can't wait to hear what works for you all. And I will be back next month for another Elementary Explorers. Bye, everybody.